let's do this one real quick. Two clay balls undergo an inelastic collision by on a frictionless horizontal surface. Ball A has an initially has a mass of this. Okay, so let's start recording our variables real quick. So MA equals 0.766 kg, and VA equals positive 0.91 meters per second. Ball B initially has a mass of this. Well, let's highlight some of these things. We can do that. Here's these first two variables that I found. And then here's this one and this one. Okay. So now we have mass B equals 0.811 kg. And then we also have VB equals negative 0.42 meters per second. When the two spheres collide, they are in contact for a total of this much time. Okay, that's something that'll come in later. But we have to go back, and there's something extremely important. This right here, inelastic. And when you see inelastic, guys, I have to stress, this means they're going to stick together. Okay. So let's take a look. I'm going to bring out another worksheet to work with. Documents. Blank. Okay. So I got a blank one. Now, these all start from one formula, and that's the P before equals P after. And that's the grandfather of the conservation of energy. And you can expand them out, but I usually like to go to this point. MAVAI plus MBVBI equals MAVAF plus VBF. Okay? Now, this is important here. They stick together. Remember I stressed that before. And when you stick together, guys, these two velocities are the same. So this can be rewritten as MAVF plus MBVF. And you can just combine these. Now you'd say MA plus MB parenthesis VF. You just factored it out. And that equals the other side. So now all you're going to have to do, let's go back to our original sheet, and we'll see, I didn't fully identify these yet. These are going to be your initials. And we're going to have a final. And you're going to find that by substituting. You see you have these four things. Now these four things will substitute into here. Then you have these two things. So that leaves you with only one missing variable. You should be able to solve for the VF. This is algebra. Okay. Find the final momentum of A. Well, let's solve this first, but I'm going to solve it on my calculator real quick. So this should just take un momento. Now, guys, I really highly recommend getting a nice graphing calculator because it's really going to help you out next year in college because they are a luxury to have. So it's MA 0.766 times 0.91 plus 0.811 times negative 0.42. Enter. And then divide that by 0.766 plus 0.811. And hopefully I got this right, but I got an answer. And this may be wrong, guys. This is the first time I'm doing it. I'm doing it super fast, right in front of you. I got my VF to equal 0.226 meters per second. So let me know if I did that wrong. Double check your answers. But that's what I got. So it says find the final momentum of ball A. Well, that's pretty simple, guys. This is actually pretty straightforward. This is just going to be PAF equals MAVF. And I can just do this real quick for you guys. That's 0.766 times this number, the 0.22, and you should get it equal to 0.1731 kilogram meters per second. Once again, guys, if I made a mistake here, it's gonna filter into these. I think I did that all right. I'm going to skip over find the final momentum of B, find the impulse of A. Okay, well, impulse, pretty simple. J equals delta P equals PF minus PI. Now I'm going to do this for A, so it's A, 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 A. We'll stop there. You know it's an A. Okay, so now that's going to equal M A V A F minus M A V A I. And all these things are back up here at the very top. So I could plug these in, but I'll do it real quick. So I've got this. I'm going to go these two multiplied by each other. This is my VF minus these two multiplied by each other. So I'm going to go this answer minus 0.766 times 0.91. And I get an impulse equal to, and once again guys, I could be making a mistake. If there's some problems, I apologize. I got an impulse for A equal to negative 0.5, let's stop that, 0.524, something like that, kilogram meters per second. And then now I'm coming down here, and I'm going to find the force that acts on A. That's pretty simple too. J equals delta P, but it also equals F net T. And so you just go J divided by T equals F net. And so you're just going to simply come up here, guys, take this impulse you just found, and you'll see up here, I underlined before, that's your time. Just divide those. This is algebra. All right, good luck, guys. See you tomorrow.